Hi, dear students. I will explain to you normal distribution. So in the class, some people told me I was a little bit fast. So I will explain to you what is normal distribution. Usually, normal distribution is represented by two values, average and standard deviation. So what is a normal distribution? In a class, if the maximum number of students has got marks near to the mean, we call that a normal distribution. So I'll just show you what is the real meaning of the normal distribution. Any distribution that has got a bell curve. This is a bell curve. See, you can see this is a bell curve. And this is the mean. You can see this is the mean value, the average of the distribution. So this will give you the number of occurrences or number of students. Suppose you are taking the case of marks in our class. So most number of students will have the mark around the mean. So that's why it is coming here. And then another term I told you is standard deviation. That is how much far your mark is from your mean. Okay, that is standard deviation. So if it is one standard deviation away to the right and one standard deviation to the left. So between that lies 68% of the students in our class. Okay, and between two standard deviation to the right and two standard deviation to the left, you have 95% of the students. And when you take 3 standard deviation to the right and 3 standard deviation to the left, you got 99.7% of the students. And when I took the outlier, I told you any value that lie after 3 standard deviation. Suppose something is here, we can call it as an outlier. That's one criteria that we have studied how to identify outlier. So what I told you now, any normal distribution can be represented by two values. That is, one is mu, average, and another one is sigma, standard deviation. So with this, this is what is called a standard deviation. Okay, and its properties can be, I told you, one is skewness. Skewness means it should not be either left side skewed or right side skewed. So you can check whether, with using that formula, you can check whether your distribution is normally distributed or not. And then another thing is a kurtosis, that is how this curve comes. So usually the value should be around 3 for kurtosis. Okay, and regarding skewness, it should be around 0. Okay, skewness should be around 0 for a normal distributed curve. Okay, hope you understood. So this is what is called a standard deviation. This is what is called a normal distribution. Okay, clear? So I told you about sigma and mu and sigma. Okay, clear to you? So this is what is called the empirical rule. Approximately 68% of observations fall within one standard deviation of the mean. Approximately 95% of all distributions fall between two standard deviations, mean, and 99.7 between 3 standard deviations. Okay, clear? So this one is more precise. So it says 68.3, and how the, so 1/2 34.1, 34.1. So just it is distributed, nothing else. As you can see, I'll just show that. This is one standard deviation, one standard deviation. So 68% is divided into 2. It is actually 68.3. So 34.1 plus 34.1. So it gives the sum of this and this gives 68 point. Okay, like that, this plus this, like that you get 95 percentage, 95.4 comes, and 99.7. Hope it is clear to you. Now I will tell you, I will ask you to do one small exercise. So what will be the value? We will fill that value we did in the class. So we did in the class, and I will show you. Hi. Now we'll do a small exercise and see how we can know more about normal distribution. So here the mean is 60 minutes and standard deviation is 10 minutes. The length of time needed to complete a certain test is normally distributed with mean 60 minutes and standard deviation 10 minutes. So let us see how we can find the values in the boxes. Okay, so what is the average? That is mean, mu, that is 60, and standard deviation is 10. So mean will be the middle value, that is where the maximum number of occurrences will be there. So this box, what it will contain? It will contain 60 and one standard deviation to the right. That means 60 plus 1 sigma, that is 70. 70. 60 plus 2 sigma, that is 60 plus 2 into 10, 80. 60 plus 3 into sigma, right? 90. So to this side, to left side. So there is one standard deviation to the left side. That is 60. You have to subtract 10 from 60. That is 50 here. And 60 minus 2 into sigma. That is 40 here. And 60 minus 3 into sigma, 30 here. So between this lies 68 percentage. Between this lies 95 percentage, 95.4 percentage, and between these lie 99.7 percentage. Okay, so that is it. That's the how we fill the values in the box. Okay, so let us go to next one. So the next question is, what is the probability that someone will take between 40 and 80 minutes to complete the test? So where will this 40 and 80 come? So let us see that. So this is 60. So 80 comes here, 40 comes here. So what is the probability that someone will take between 40 and 80 minutes to complete? So 95 percentage of the values will be lying here, but that is not the answer for that. So how will we find? So we have to find what is the how 95 percentage. So how we have to find that 95 percentage? Okay, how? What is the probability that someone will take between? The answer is 95 percentage. Sorry for the mistake. So how to, you from the empirical values you can see it is 95 percentage, actually 95 percentage. Okay, I'll come to that how to find that 95 percentage. Okay, so coming to the next question, find the interval that contains middle 68 percentage of completion times for all people taking the test. That you know it will be between one standard deviation to the right and one standard deviation to the left. So it comes 50 and 70, between 50 and 70. So next question is little interesting. What percentage of people take more than 80 minutes to, I will just take the screenshot of this one. Question is, what percentage of people take more than 80 minutes to complete the test? So I will have to, so it is 80 minutes. Okay, so again I will go to this one, 80 minutes. So question is, what percentage of people take more than 80 percentage? So more than 80 percentage. Okay, so as you know, the suppose I am drawing the normal distribution. So here comes this is the more than 80 percentage, 80 minutes, sorry, here it is 80 minutes, not 80 minutes. Okay, so here comes 80. So we want the value to the right of 80. Okay, so we find the probability value of p value till here and subtract. I forgot to tell you one thing. The area under this curve will be 1. So if you get the area, this area, you can subtract 1 minus this area, you will get this area. Okay. So the formula gives, you have to use the formula Norm.Dist. Okay. And the arguments for that are x value, that is 80, what to what value, till what value. So less than 80. Okay, this value is 80, x is 80. Next one is mu, that is 60. Then next is standard deviation, comma, whether it is a cumulative function. So cumulative is true. So cumulative false means you will get on that point. So we want less than that point. Okay, so you use the true. If you use false, you will get the value at that point. That's not what we want. We want less than 80. Okay, so we'll see how it is done using this formula in the Excel directly. Equal to, use the function Norm.Dist. So just click that. So you can get help from by clicking that link. You'll get the help of this function. So x value here is 80, comma, what does it mean? 60, comma, 10, comma. The asking whether it is a cumulative distribution or not. So it is true. Enter. Okay. So you got this value. So what is this value telling? This value is telling less than 80. What is the percentage of people take less than 80? Okay, from the graph you should understand it is less than 80. So what will be more than 80? Equal to 1 minus this value. So that will give you more than 80. Okay, I'll tell once again. this is 60, this is 80. So 0.9725 will be this area till here. So to get this area, we have to subtract this area from 1. That's what we did here. 1 minus this area, the shaded area. That is 0.97725. This gives this value. Okay. Hope you understood. Okay. So now some people are asking me, how you got 68%? Okay. That means this value. How we got 68% value. Okay. So we are going to use two formulas and find how we are going to use that. First formula is what I told you is Norm.Dist. So what is 68%? So 68% means what is it? It is between, if you draw your normal distribution, it is between 1 sigma to the right and 1 sigma to the left. So this area is 68%. So suppose our distribution is represented by 60, 10. How you can find that? You have to find the value less than this area and less than this area, and you can subtract, and then you will get this area. So let us try whether we are getting 68%. Okay. So what will be the equation for that? Equal to, okay, I will close this and then we'll try how we are going to get these two values. I have done by two methods. One is using Z and another one directly. So okay, so I'll tell you about Z and then I'll come back to this. Okay, I'll tell you what is Z score. So what is Z score? So actually I told you about these two formulas. So actually these two formulas are same. There is no need of any confusion for this formula. I will tell you that. Okay, I told you first this formula and then I told you this one, but actually both are same. What is actually Z means how far from the from the mean the value will be. Okay, if you get a value, how far that value is from the mean. To find that, we use the Z score. Okay, so here S bar means, what is S bar? S bar is the average of the samples. Average of samples. Okay. Mu means average of population, entire population. So we take some samples from that population. So average of that samples is S bar, and average of entire population is represented by mu. Sigma, standard deviation, is the standard deviation of entire population. N is the number of samples taken. Okay. So let us see how these two are same. Here X means one data point. Okay. You got a array or a column full of values and you take one value. That value is X. Okay. So for that one value, the average will be that same value. So X and S bar are same. Mu is same in both. So even if you do sigma by root n, so here n is 1. So this get cancelled. Okay. So what you will do, if you are given one sample size and population, you use this formula. So if the n is given, you can directly use this formula. Okay. So if it is a data point, you are taking a random one value, then you use this one. Both are same. Actually, somebody asked me that doubt whether these are same. Okay. So how will you find the z value? Either z equal to, I'll show you an example, x bar, that is average of the sample group, x bar minus average of the population, s bar minus mu, divided by sigma, standard deviation of the population, divided by root 10. Okay, so this tells you that average or data point, how far is it from the mean mu. Okay, so example is set score example. Suppose you got a data sheet that contains the name of the American president and his or her height. It is given in the inches. So we find the population mean mu and population standard deviation sigma by using the respective formulas average and standard deviation. Standard deviation is STDEV dot P, that's for the entire population. And we took a random height 72. And suppose you want to find the z score of this single value, what will you do? You will substitute z equal to z equal to this value minus mu, we will put bracket here, divided by standard deviation. Okay, you put here. Okay, so this is a z value. So it tells you this 0.48 away from, so it is not even, it is lying between 70 and 72.71. Okay, so standard deviation is 72.71, so it is 72, so it is 0.48. Okay, now let us try one example here. What is the sum of mu plus sigma equal to this plus this one? Okay, you got a value. Okay, you're going to find z value for the corresponding. So how will you find? Equal to this data point minus mu, the bracket, divided by the standard deviation. You get 1. Hope you understood now. That is, mu plus sigma will be 1 z value from the mean. Okay, hope you are clear. So here what formula you used? You used x minus mu by sigma. Okay, suppose I had told about the hypothesis. So you took the some 9 random presidents were selected and its value heights are given. So then what formula will you use? You know just 9. So you use the other one, S bar, that is the average of this one, sample mean x bar, S bar minus mu by, we can see how it is, suppose this is the case, equal to bracket s bar minus mu divided by again bracket sigma divided by square root of n, that is 9. Okay, so when you took this entire population, why it came negative? This is 70.1 and 70.6, so it will be to the left side. Hope it is clear to you. So this is how you use the two formulas. If it is one random height, then you use x minus mu by sigma. Otherwise, if the n is given, you take the other one, the standard formula, s bar minus mu by sigma by root n. Okay, hope you understood z score. So how you are going to find how you get 68%? Okay, so I'll just tell about that. How you get the 68%? What they're going to tell you. So this is your normal distribution. So one standard deviation to the right, one standard deviation to the left. So I told you it is 68%. How we got the 68%? 68%. Suppose our distribution is represented by 60, 10. Okay, how we are going to get that? Let us see that. Okay, so here what formula you will use first? Norm.Dist bracket, you will give the value here, that is 70, 60, 10, true. So you will get this value. Okay, first value, this value, and then you give Norm.Dist. Arguments will be this value, that means 50, 60, 10, true. Okay, so you got two values. So subtract this value minus this value, you'll get it. So let us try how we will do that. Okay, 68%. Okay, 68% equal to Norm.Dist. You give 70, 60, 10, true. Equal to Norm.Dist to the left first. So that is 50, 60, 10, true. You got, so what you do, you have to subtract equal to this minus this. You give it a percentage sign. Okay, 68%. So now I will do it using z value. Okay, for that the equation is Norm.S.Dist. Okay, I use that one here, so we will try that one. Norm.S. So S corresponds to, if you are using z value. Okay, let us, so what is 68% now? 68% is coming by, suppose you draw the normal distribution in terms of z means. This is mean, it lies between one standard deviation to the right and one standard deviation to the left. Okay, so this area is having 68%. So how you get 68% using Z score? Okay, so the formula is equal to Norm.S.Dist. So what you have to give the Z value? Z value is 1, comma, true. Okay, you got the same one. You can see this value and this value and this value are same. We use two different methods. So here again norm dot s dot. So what will be the Z value corresponding to 50? We took 50 in the above case, so it is minus 1 comma true. You can see you got, so again equal to this minus this one. Okay, you got 68%. So this is how you get it using Z score method and direct method. Okay, so let us see. 99.7% you do what I have done here. So I just try 95%. Okay, equal to. So what is 95%? 95% means I'll draw that graph for you. What is 95%? 95 means norm distribution. So 2 standard deviation. Okay, that is 60, 70, 80, 80, and here 50, 40. So that is between 40 and 80. Okay, that is for 40 and 80 for Norm.Dist. So if you are using the other one, Norm.S.Dist means what? Your normal distribution is 2 standard deviation. Okay, 2 standard deviation and minus 2 standard deviation. So when you're using standard deviation, you use the formula Norm.S.Dist. Okay, this is for the 95%. Okay, so how we are going to get the 95%? That's what we are going to see. Okay, so first one, Norm.Dist. What is the value? 2, that is 60, 70, 80. 80 comma 60 comma 10 comma true. Okay, and to the left side, Norm.Dist 50, 40. I told you 40 and 80. 40 comma 60 comma 10 comma true equal to this minus this one. You got 95.4. That is what we want. So we will try the other method during the Z. Norm.S.Dist is 2 standard deviation, 2 comma 2, and 2 standard deviation to the left side. Norm.S.Dist minus 2 comma true equal to this minus this one. Okay, so 99.7% same method, you will get both the values. You can try yourself. Okay, I will leave it as an exercise for you. You try that. So I think now you have, so what all we studied now? Just a recap, what all we studied? We studied First, I'll take a blank. Okay. Recap what we studied. So, normal distribution, and then we studied what is it, how it is represented. That is represented by mu and sigma, and then mu and it, one standard deviation, two standard deviation, and it is same to the left side. And I told you about 68 percentage, 95 percentage, 99.97, 99.7 percentage, and then Z score, and then I told you about two formulas here: Norm.Dist and Norm.S.Dist. So two more formulas are there corresponding to both. One is Norm.Inv, the inverse of this one. So what you got from this one? You got a p-value. Okay, so that's what you get. Always the p-value is between 0 and 1. So if you got a p-value, what will be the, suppose in our case, what will be the mark? Suppose you are getting a p-value as 0.997. What will be the corresponding mark? For that, there's an equation called Norm.Inv. And here also you got a p-value. So if you got a p-value, what will be the corresponding z value there? Okay, for that you have got an equation Norm.S.Inv. So I will tell you about, I will show you some examples of that later. Okay, so I will tell you about some examples we'll see later.